We've been working on factoring polynomial expressions, and so today we're going to continue on that trend. So we want to factor the expression 3x squared plus 8x plus 4. Steps that you want to think about when you're trying to factor your polynomial expressions is, does it have any greatest common factors? And if we look at all the terms here, we can see that they have nothing in common that we can divide out. So we also know that it was quite easy for us to factor polynomial expressions when they had 4 terms. So remember, when they had 4 terms, when you had 2 factors multiplied together, you originally had the 4, and these two are alike. That's why it simplifies down to the 3. So to help us get it back to that pre-simplified format, we look to see our expression in standard form and take that leading coefficient times the constant and put that value here. So we're thinking what times what gives us the product of 3 times 4. And then we're going to think those same 2 items, when added together, gives you that linear term 8. So again, what times what gives us 12, and what plus what gives us 8. So we start with the product, thinking what do we multiply together at 12? Well, we could use 1 and 12. We can use 2 and 6. We could use 3 and 4. But again, when we have the 2 values, they also have to add to get 8. So using the factors of 12 that meets both of those requirements, that would be a 6 and a 2. So again, we're going to rewrite that linear term of the 8x using the 2 values here. So we're rewriting it as 3x squared plus 6x plus 2x. There's the 8x that we had before, plus 4. So again, we said once we had the 4 terms, we could easily divide them into pairs and see what they have in common and divide out from each pair. So in our first pair here, we could divide out a 3x, and our second pair here, we can divide out a 2. So that would leave us with 3x times x plus 2 plus 2 times x plus 2. We can see that x plus 2 is being multiplied by both 3x and 2. So we're going to write it as the quantity x plus 2 being multiplied by 3x plus 2. There's our factored form. So let's take another one. Here, let's look at 5x squared minus 6x plus 1, and we want to factor that completely. Again, the steps you want to ask yourself is by looking at the terms, do we have any greatest common factors? And again, we look at each of these and see that they have nothing in common to divide out, so we go to the next step. We're going to think about our product and sum rule. So, are there 2 numbers that we can multiply together to get 5 and add to get negative 6? Well, we know that negative 5 times 1, negative 1 equals 5, and 5 plus negative 1 is negative 6. So we're going to use these and write our middle term here, our linear term, negative 6x, is the 2, 5x that's negative, and the negative 1x. Again, now we've got our 4 terms, so we're going to divide them into pairs and see what we can divide out. So the first pair we can see we can divide out a 5x from each, and the second pair we can divide out a negative 1. So here we can easily see that x minus 1 is being multiplied by both 5x and negative 1. Therefore, our factored form would be x minus 1 times 5x minus 1. Here we're trying to factor 2x squared plus 7x plus 3. Again, the steps that we want to go through haven't changed. We take a look at our polynomial and ask ourselves, is there a greatest common factor? In this case, there is not. Then we're going to think about our product sum rule. What times what gives us 6, and what plus what gives us 7. Again, to meet the 2 requirements of multiplying to get 6 and adding to get 7, we have our values of 6 and 1. So again, we're going to rewrite our polynomial with 4 terms using these as our 2 linear pieces. So we have 2x squared plus 6x plus 1x plus 3. Now that we have our 4 terms, we're going to look at them in pairs and divide out what they have in common. So for our first pair here on the left, we could divide out a 2x, and our pair on the right, we could divide out a 1. So we can see that we've got x plus 3 being multiplied by 2x plus 1. Therefore, our factored form would be x plus 3 times 2x plus 1. Again, we want to factor our polynomial. First step, look to see if there's a greatest common factor that you can divide out. As we look at our polynomial, they do not have anything in common that we can divide out. Then we're going to think about our product sum rule. What times what gives us 12, and what plus what gives us 13? Thinking about my factors for 12 that add to 13, I could use a 12 and a 1. So again, we're going to rewrite our polynomial using our values here for our linear terms. So we have 3x squared plus 12x plus 1x plus 4. We take our 4 terms and split them into pairs and divide out what we can from each. Our pair on the left, we could divide out 3x. The pair on the right, we could divide out a 1x. Sorry, just a 1. So we can see that x plus 4 is being multiplied by 3x plus 1. Therefore, our factored form would be x plus 4 times 3x plus 1. We want to factor 7x squared minus 15x plus 2. Again, you look to see if they have anything in common that you can divide out. Is there a greatest common factor? In this case, there is not. So then we're going to think about that product sum. What times what gives us 14? What plus what gives us negative 15? So thinking of your factors for 14 that would meet both requirements, we can use a negative 14 and a negative 1. So again, we rewrite our polynomial with the 4 terms. 7x squared minus 14x minus 1x plus 2. Divide the 4 terms into pairs and divide out their greatest common factors. So the pair on the left, we could divide out a 7x. The pair on the right, we could divide out a negative 1. So we'd have 7x times x minus 2, and then you've got your negative 1 times x minus 2. X minus 2 is being multiplied by both 7x and negative 1, and we have our factored form. Here we want to factor the polynomial x squared minus 6x plus 8. Again, look to see, is there a greatest common factor you can divide out from every single term? In this case, there is not. So then we're going to think about our product sum pattern. What times what gives us 8? What plus what gives us negative 6? So to meet both of those requirements, we would use a negative 4 and a negative 2. Rewrite the polynomial using these two to represent your linear term. So you've got x squared minus 4x minus 2x plus 8. Take your 4 terms and divide them into pairs, and divide out what they have in common. So the pair on the left has an x that we can divide out. The pair on the right has a negative 2 that we could divide out. We can see that x minus 4 is being multiplied by x and negative 2. Therefore, our factored form would be x minus 4 times x minus 2. Factor your polynomial. Step 1. Does it have a greatest common factor you could divide out from each term? I can see that both have a factor of 3 as well as a factor of x squared. So if I divide out a 3x squared from each term, I have 3x squared times 1 minus 4x. There's nothing else that looks like I can factor, so this would be my factored form. 3x squared times 1 minus 4x. Factor the polynomial 2r squared plus 7r minus 15. Again, first step, is it have a greatest common factor that you can divide out from every single term. And if I look, they have nothing in common to divide out. Therefore, we're going to think about our product sum pattern. What times what gives us negative 30? What plus what gives us 7? With our number patterns, we can use a negative 3 and positive 10. Again, rewriting our polynomial with 4 terms, we have 2r squared minus 3r plus 10r minus 15. Take your polynomial and divide it into pairs. Divide out any common factors for each pair. So the first pair on the left, I could divide out an r. The pair on the right, I could divide out a 5. So I have r times 2r minus 3 plus 5 times 2r minus 3. We can see that 2r minus 3 is being multiplied by r and 5. So our factored form is 2r minus 3 times r plus 5. We want to factor the polynomial y squared minus 64. Again, step 1, does there exist a greatest common factor between your terms? In this case, it does not. I can see, though, that there are 2 terms in our polynomial. It's a quadratic. We're typically seeing 3 terms in a quadratic and expanding it out to 4 to help us factor. So let's kind of think of the same thing here. We're missing the linear terms. I'm just going to write it with my 0y as a placeholder. So now I'm going to think, what times what gives me negative 64, and what plus what gives me 0? Well, to make that happen, I would have to use a positive 8 and a negative 8. Again, we rewrite the linear term using these as the guides. We have y squared plus 8y minus 8y minus 64. With the 4 terms, again, we'd like to split it into pairs and divide out what they have in common. So the first pair we can divide out a y, the second pair we can divide out a negative 8. So we can see that y plus 8 is being multiplied by both y and a negative 8. Here our factored form has to be y plus 8 times y minus 8. Last one, we want to factor the polynomial 11x squared minus 50x plus 24. Again, does it have a greatest common factor? So if I look at each term, I can see there's nothing in common I can divide out. So I'm going to think about the product sum. What times what gives us the product of 11 times 24, which is 264, and what plus what gives us a negative 50. So if I'm looking at my multiplication table and I find 264, I'm finding things that add up to like 34, but I can't get anything to get me close to a negative 50. Well, if I can't find a number pair that will meet both requirements for the product and the sum, this is what we call prime, not factorable. At this point, you're going to work on your homework assignment for today, and we'll check your progress with your factoring tomorrow.